We're recording. Will it pick you up? Oh, maybe I need to get out of frame so it's not.
Oh,
Oh, I got to turn the background off for this, I guess. All right.
you would think it would pick it up.
No, it probably is not. It's probably not finding you as human.
The creature.
I think it's in the settings. Virtual backgrounds, just choose none.
Oh, yeah, there we go.
All right.
It is
Here.
a creature tonight.
All right. So you've been saving up for this?
I mean, I had the money for it.
In the middle so that way they can see.
How much? Yeah. Make sure you get centered in this thing.
Right.
All right. So okay. So you had, how much was this?
It was like 70.
$70? Okay. I mean, it's not horrible.
Yeah,
It's well made.
I mean, it's
It actually is pretty sturdy. It's not like
well,
not like cheap plastic.
they literally gave it to me over a gun counter.
I'm amazed.
They actually sell this as like legit armor. This is in their hunting section.
Yep.
Oh my gosh.
Well,
What store is this?
Shields.
Oh. And they just sell stuff like this?
Yep.
Do they have like a full suit of plate armor and stuff?
They don't have a full suit of plate armor, but they do sell armor.
Because I think isn't this like a jousting helmet?
I thought it was Crusader
A
helmet.
Crusader helmet.
Yeah.
You seem to know a lot about this.
Death and destruction.
Exactly.
For those online, I said, you seem to know a lot about this. He just looks at me and goes, yeah. All right, let's get rolling. Oh.
This is beautiful. So beautiful. I want to. At 10, 11 interval.
Let me get my background back on so I don't forget. Do the red one? Oh, that's for Ann Arbor. So I would do that if we were in some I don't know, whatever. Oh, the shirt today, this is Gremlins. How many of you remember Gremlin? Well, it was before your time, but how many of you saw Gremlins at like a retro event or something? Gremlins had to be here. Early 90s, late 80s? Probably was 80s.
I saw one through.
84? Hey. I remember waiting in line for that. I was a kid. I was born in 78.
But dinosaurs flies back then.
Actually, Dr. Locklear, old Locklear, Gary, yeah, dinosaurs did exist when he was a kid. Ask him about it.
Like if your parents are in like their 50s, like that's pretty.
Yeah, I'm probably a similar age to most college age students' parents. Maybe a couple of years younger. I'm guessing most. Oh, we were talking about threads. All right. So last class, I know several of you had already gone home early. Hopefully you watched the lecture or whatever. So we were talking about overcoming blocking code. When we have, like, for example, inside of our dungeon right now, we get to a place where it's asking the user, what do you want to do next? So it's sitting there waiting for keyboard input from us. Well, we might want our game to feel alive other than that. So that means that while it's waiting on us to do something, we want to be able to have other things occurring. And in order to overcome that, because when it's waiting for us to type something, the program is blocking the rest of the stuff from being able to happen. And the way we can accomplish that, now, if you go back and watch the last video, we talked about kind of the history of this stuff, multiprocessing, the idea of a process versus a thread, yada, yada, yada. This is all the technical stuff under the hood. I don't want to recap that here. But the way we modernly overcome that is through threads. So we had already talked about threads a little bit. We were talking about interfaces, and we looked at the runnable interface. And the runnable interface basically just says, if you want to implement this, you must write a method called run. So let me go ahead and just to remind us, we're going to go to, do I have Tinkercad up here? Oh. sometimes I use that for designing my 3D print stuff when what I'm doing is simple and I don't need to go use Fusion 3D, which I know how to use, but I'm not all that great at modeling. So if it's a simple enough thing, I could just do it in Tinkercad. I actually designed something in Tinkercad this morning. That's why it's up. I can't tell you what I designed though. It might be incriminating. All right. So anyways, we're looking at the thread class here. And there's an important nuance here. Notice here that the thread class in Java, first of all, it lives in the base language. So thread only inherits from object. So if we look at our inheritance model, so it's a very high level object in the Java language. And I want us to view this thread class as being something that's tightly entwined with the operating system. Because it's important that if we want to have this background stuff happening, we get to it by way of the thread class, rather than implementing our own class that implements runnable. Runnable is not what makes it magically run in the background. Runnable is effectively saying, this is a set of rules. Anything that is runnable, if we come here to the interfaces that it implements, we see that there's implementing classes here. So we have, actually, this has some stuff in it we talked about last time. So most of this is thread stuff. We have this thing called asynchronous. So if you've ever worked with anything or followed a tutorial and they have something that says like async, ASYNC, or asynchronous, they're talking about things running in the background, non-blocking stuff. So that's almost a synonym. Threads give you asynchronous behavior. Not all asynchronous behavior is accomplished through threads, but modernly, really most of them are. All right. But we see that there's some other things. Oh, here's a future task things. This is like a thread scheduler, effectively. So we have other things that implement runnable, even though they all seem like they're pretty thread related. But for us, if we wrote our own class called test class and we implemented runnable, and then we wrote our own run method like the runnable interface dictates we must do, there's only one thing, one requirement to be part of this club. Write a function called run. If we do that, it will not run in the background. The thread class has the magic in it to make it run in the background. Go ahead.
Classes that you mentioned about. So do we ever put those classes, like when we're creating a class, do we ever use those?
That's the right tool for the job.
Okay.
I mean, imagine that, what we're seeing here when we're looking at this. I mean, this is something that, I've never used async box view or join worker thread. I join other threads through the thread class. Maybe it does it with this. And maybe you've used future task at some point that's like saying, I want something to happen in 10 minutes. And you just throw it off to the side. But, the Java language has zillions of classes. Each one is a tool that's built to solve a specific job. So our overarching goal as programmers is always use the best tool for the job that we have available to us. That might mean stuff that's kind of in our wheelhouse that we've worked with before, that we can wrap our mind around. And then as you get more and more advanced, you can pick up any of these tools, look at the documentation, and just start using it. Go ahead. Thread makes it actually run in the background. Runnable actually has nothing to do with background stuff. Runnable just says, look, I'm the name of a club called Runnable. And if you want to be a member of this club by implementing the club, the only thing you have to do is write a method called run inside your class. It has no implication about running in the background or anything like that. Just a club membership that doesn't mean much. So we just happen to use runnable to introduce interfaces because threads happen. So here's our thread class. This guy happens to implement runnable. If it didn't, it would still be able to pull off the same thing it's doing. We would just put our code in a different place than run. So if we look at the methods that are inside the thread class, here's our constructors, the different ways we can create threads. We can give it a name. We can just build a generic thread and just use the variable name as our thing. And we'll look at these today. We're going to run some threads today. But inside here, we see that we have a run method. Okay, so this method right here that lives inside the thread class was how the thread qualified to be part of the runnable interface club. All right. They chose not to do that, but still put a run method there or still put a method named whatever there. Not a problem, because the magical method inside threads is not run. You never tell a thread to run. You tell a thread to start. There is a method down here called start. This guy is the magical method. Inside start, there is stuff that as programmers in a language like Java, we can't do. It gives you access to operating system level stuff by way of the Java virtual machine that we can't do on our own. It's letting us schedule stuff at the OS level. So our mechanism to tell this thread to start doing the magical stuff is call the thread start method, and it will do what it needs to do to create this asynchronous thing that can go and do whatever we tell it to do inside of run. So effectively, we put our logic inside of the run method. And the start method knows that, okay, I'm going to do all the thread things, that thread magic, and then I will call your run method, and that's what that thread will do, whatever your run method says to do. Make sense? And it'll go through it just one time. So if you wanted to continue repeating a behavior, you got to put that in a loop. All right. So let's now just look at this through examples instead of talking about it at a high level. All right, what do I got here? Too many tabs. Okay. Didn't I? Okay, yeah. So last time, or one of the times, we started writing this class called worker bee. All right. So right now, this guy is just a plain Jane class, nothing special about it. I can create instances of worker bees, and I'm going to go ahead and I'm going to put in a public void run method in here. And I'm just going to do a system.out. Println, whatever. All right. So now I have left some stuff out. We're going to roll into it here. So actually, let me do this just for a second. So I'm going to remove that function. I copied it. We're just going to put in that this guy implements runnable. So we've advertised ourselves as being a member of this interface, a member of this club. So if I go into driver, let me just finish the thought here real quick. So if let me just comment these things out.
Professor Livin,
Yeah, go ahead.
did you share the screen?
You waited this long to tell me to share the screen?
Well, I was just making sure that I was correct.
Oh, yeah, I hadn't shared it, but thank you. All right, you can see it now, I assume?
Yep.
Okay. All right. So if you haven't seen it before, that's a multi-line comment. Hopefully you've seen it at some point. All right, so I'm going to go ahead and I'm going to create a worker bee here. Now, if I look at my worker bee class, Ninja, no, okay. My worker bee class requires a string to build it, so I'll just go ahead and give it a name. Worker bee WB1 is equal to new worker bee, and we'll call this guy WB1. That'll be his name, worker B1. All right, so I haven't done anything else other than create an instance of this guy. But now keep in mind, when I look at worker bee, I have said that I intend to implement the runnable interface. Yet I have not written a run method. So if I go and try to run this guy, it's going to scream at me. Worker B is not abstract and does not override abstract method run. Remind me, what does abstract mean?
Like you can't create.
Okay. You can't create, so if a class is abstract, we cannot directly create instances of that class. So it exists for the purpose of inheritance. But secondarily, now you see the existence of the idea of an abstract method. That is, this is the method that through inheritance, you do not automatically get. You must implement that method. Make sense? So we actually have kind of two ways of forcing someone to implement something. We can do it through a club membership thing, an interface, but then we can also internally say, look, you don't have to implement all these methods, but if you want to call this one, so for instance, if we have a method, an abstract method called run, we don't have to implement it if we don't want to. We only have to implement it if it's an interface we're implementing. But if we inherit from a class that has an abstract method, that does not require us to write it, but it does say you do not automatically get this method by inheriting from it. This is a method that if you want it to exist, you have to write it yourself. Make some sense? So it kind of is a have-z requirement type thing. So we see the error here. Go ahead.
What is the point? Like having that method.
You're going to see we're rolling into that right here. All right. So for starters, we see that I have claimed that I'm going to implement runnable, but I did not fulfill the requirements of that. I'll go ahead and just paste in that public void run method. So now I have fulfilled the requirements of this. So if I go ahead and run now, it's not going to scream at me anymore. Program's not going to do anything because all I've done is I've commented everything else out. All I've done is created an instance of something and done nothing with it. All right. Now, if I say WB1.run, which I'm allowed to do, what is it going to do? Well, it's going to call this run method, just like any other class. If you call a method in that class, it'll just call that method, and all this guy does is print out LOL. All right, so it prints out LOL. Now, what we're trying to accomplish here, though, is having something that runs in the background so we can have blocking code or have multiple worker bees off doing their own thing. All right, so kind of think about this. What we're trying to accomplish here is we just had a big snowfall and we wanted to clear all the snow here on campus. Well, up to this point, we've only been able to write a program that implements a single snow shoveler, right? Who can go and shovel snow at whatever speed they can shovel snow at. But we know that if you get 50 guys out there shoveling snow, you're going to get it cleared much more quickly, right? Well, until now, we didn't have the ability to write a program. I'm creating some loose connections here. We didn't have the ability to write a program that allowed us to create 50 helpers to solve parts of a larger problem that can be subdivided. All right. And that whole argument we just made is the same thing as we would make as to, well, is an 8-core processor faster than a 4-core processor? Depends on the job you're asking it to do. If it can be divided into 8 steps, well, probably. If it can only do one thing at once, well, it's going to depend on who has the fastest single core. Go ahead.
So there's the main node number, the main node going in a direction. Are the worker bees like off in a different, the analogy, off in a different part of parking lot shoveling, or are they checking the first snow shoveler's shovel to see if he's stopped?
Whatever we tell them to do.
Okay.
Yeah, effectively, it's whatever we tell them to, how we tell them to behave within the run method. So for threads, run method is our main. All programs, all threads begin and end with run. They start at the beginning of run and they do whatever we tell them to do for as long as we tell them to do it. And they're off in their own little world, getting some CPU time and all that stuff. All right, so at this point, we've said we've implemented runnable. But this doesn't give us any of the magic we're actually going for. To get that magic, what we're going to do is we're going to say, I want my worker bees to extend thread. I want to inherit from this class that came with the language called thread that happens to implement the runnable method, which really is not that important to us in this particular case. It was just an opportunity to introduce the idea of interfaces. They're not super commonly used, but we are extending something that already exists that happens to have this magical ability to do asynchronous stuff with the operating system. It's our way of getting at the operating system through the Java virtual machine. Now, if I take out run here, we have not claimed that we are implementing runnable. Thread, though, we saw from the documentation, does implement runnable, which means threads already have a method called run. So I'm going to go ahead and run this. Actually, I need to take a line out here real quick. No. Implements is only something that exists for interfaces. So, and like I said, it's not super common to use them, but they do exist. It really is meant for making sure various things are compatible with a standard. That's what interfaces are for. Extends is 100% inheritance. Create classes or take a class that already exists, as we have right now, like thread. And I say, you know what? I understand that generic threads exist, but I don't want to be a generic thread. I want to be a thread that does something custom for what I want my threads to do. Make sense? Because the default thread actually doesn't do anything by default. So if I tell this thread to start, which I promise you that tells it to do the magic. But because I have not, inside of worker bee, I haven't written my own run method, it's going to call the thread's default run method, which does nothing. So I promise you what just happened there is some operating system stuff. We had this brand new worker bee. We said, you start. And it then went and did the magic with the operating system, took up system resources. The default run method that came with thread does nothing. Therefore, our program did nothing. But we did use up system resources spawning off a thread that did nothing. But if we wanted to do something, we can go into our worker bee. I think I probably could just do that. And now we've given it our own run method that does one thing, but doesn't necessarily do it multiple times. Just does one thing. So let me run it real quick and then we'll. So now all I've done is I've added a run method into my worker bee, but notice I'm never calling run. I'm calling start. Start's our magic method for threads. It will then call our run method, which we're going to see here. We're going to see a LOL to the screen or whatever I printed. All right, so that came from an asynchronous thread that was running behind the scenes, not in our main thread here. All right, go ahead.
When it comes to us creating our own like run method, is that it's not exactly the same, but in my mind, I think of it like the two-string method. Like it already has its value, but then you like come in and we add our own.
I would say thinking about it like the two-string method is fair. The two-string method comes with object. Threads inherit from objects, so they have two-string. But what we're doing is we're saying, okay, I know threads come with a run method, but I want it to be a more specialized one. The default run method does nothing. The default two-string method prints out that memory addressy looking thing. So if we want something other than memory addressy stuff, we write our own version of two-string. If we want something other than nothing for our threads, we have to write our own run method. Go ahead.
How are threads handled by the CPU?
Well, you didn't watch my lecture from last class and when you went out of town, did you? Go watch my lecture and you'll understand how We probably spent half the class talking about how CPU schedule threads. Huh? Oh, killing me. I have a link to them on to the whole playlist on
Find them, I just forgot.
oh, I think it's on campus. There's a link to YouTube lectures under modules, I think. It takes you to the playlist. And once you're at my account, you can see classes for the last 15 years on there. If you want to see a really cool class, I think it's in 2008. I taught a class here on blockchain using Bitcoin. 2008, Bitcoin was not worth what it's worth today. So we were writing a voting application in class, to like effectively a secure voting platform. So we're transacting like 1 Bitcoin per vote during class. So during class, by today's standards, we were moving hundreds and hundreds of thousands of dollars. But back then it was, 15 cents or something. But you can see like my Bitcoin balance and a lot of Bitcoins in there.
Any of them or did you get rid of them?
I sold everything after they hit 80,000. Pretty good week. Over 6,000.
6,000.
Yeah.
Bitcoins for
80,000?
That is
So 480 million?
Wait, so why are you keeping it?
Yes.
All right. Well, I mean, I've made more money in that selling my businesses. I mean, money's fleeting. In fact, I feel like I'm the example of why you shouldn't chase the dollar. I've been at my most unhappy when I was trying to make money. The Bitcoin thing is random luck, right? I'm a geek. You play with new tech that comes out. I happen to get into the mining Bitcoin stuff. I was mining it with my CPU first. Then other people are mining. I mined it with my GPU. Then I got specialized equipment, ASICs, application specific integrated circuits. And then, moons aligned. Same thing was true with my first iPhone app, the dice roller that made bucks. These things you just right time, right place. That has nothing to do with intellect. That has nothing to do with anything else. Just luck. So, but I was at my most unhappy when I was chasing the dollar, because what are you going to spend it on?
When you have an infinite amount of money, you get to a point where you like reach above the clouds and you're like, there's nothing else.
Well, I had this conversation. So I go around, I kind of teach on apologetic stuff, and I had this conversation with somebody a couple weeks ago. Life gets very boring when you don't have goals. So let's say that there's a vacation you're saving up for. Big family vacation. Let's say it's going to be 10 grand to do it right. Well, most people say, okay, we want to take a big family vacation next year. We're going to save up for this, blah, blah, blah. So there's this goal. Everybody's getting behind it, all this stuff. I don't have that. You want to go on a 10 grand vacation? You just swipe the card. Sounds fun, but the reality is you kind of lose this, lose goal setting. So, I guess when I sold all my companies in 2014, I probably kind of became a very different person. I was always chasing the dollar. I couldn't, I looked myself in the mirror. I'm like, this isn't the guy I want to be. Just every single day, it's how can I make more money? Stupid. So I was already teaching here at the time. When I started teaching here, was to train my interns to code. So I would hire them as interns while they were students, and then I would cherry pick the good ones and write letters of recommendation for the ones I didn't want to keep. But I don't know. Now I've collected all this crap and these cobwebs up here, and I don't sit there and do it. I don't code all day long for things other than my little projects. So I get them 80% done. They work for me, but I don't try to make them pretty or anything. So now I got to get what's in here out to the young people that are going to go and change the world. So I guess that's my motivation. Although I'm less motivated the last many years with I would say many young people being less interested in learning than historically they were. It's more of a transactional thing. Like, here's my 100 grand, give me a degree. Then they go out in industry and can't do anything. So don't be one of those. But now I walk around and I have my fun shirts.
That's the motivation a lot of us strive to have.
My wife complains that we're losing space in the closet, so I told her she's going to have to get rid of some of her clothes.
How'd that go?
Well, what fine? I'm the boss.
But they all say.
All right.
Warden boss.
I'm the warden's boss. Something doesn't line up there, right? I do call my wife the warden, by the way. All right. So, anyways, we've seen our magical method here start. The start method is going to go and call this run method. So that's ultimately what start does. It does its magic. It calls the run method. So now if I wanted to keep doing this LOL thing, I can do something like while true or something. Throw this guy in here. Yeah, I want this to run forever effectively right now. All right. Now, what I'm going to do though is I'm going to, instead of printing out LOL, remember my worker bee here, when I built him, he was built with a name. So I'm going to go ahead and print out the name of this guy. And then we're going to create multiple threads. We're going to have them all start, multiple worker bees, have them all start, and we're going to see them competing for CPU time that you're going to learn about from watching the video. That was at you. See, he's already beat up. We're only 40 minutes into classes. Garbage. All right. So we're going to go ahead inside here. We're going to print out our name. So we're going to say this dot name. I'll go ahead and run it right now. We're only creating one worker bee. We're telling him to start. It's just going to print out WB1 over and over and over again. But I promise you that's something that's going to happen inside of a thread. In fact, just so we can see that here, I'm going to do a system.out.println before. And then I'm going to say after. Well, we will. I'm going to actually do something else here. So I'm going to say before, then after, and instead of saying while true, so it'll run forever, I'm going to say int count is equal to 0 while count is less than 10. I just need to make sure it gets enough CPU time to show my point here, but then we'll put in something that actually blocks. Oh, did I not save that other file? Or did I not increment count? I didn't increment count. All right, so there's my before. After printed out pretty quick because that thread didn't have time to get in there. So let me do, the thread takes a second to build up where it just hit that next line. We do see that thread was doing its stuff and after was still allowed to happen, but let me prove it a little bit better. So I'm going to say scanner input is equal to new scanner system.in. Then we'll say string line is equal to input dot next line. Enter something. have to import java.util. Actually, we'll just do this. Not that that was any faster. All right, so we saw that this happened before. We saw that this guy went in there to do something. We know that this code right here blocks. It's still blocking right now. It's waiting for me to enter something. All right. Now, what I'll do just so we can see this going, I'm going to change this to, I don't know, let's change it to 100. Let's just see if we can get my prompt asking me to enter something somewhere in the middle of the thread running. Doesn't necessarily matter, but just so we can see it happen. No, it's happening too quick. I can say, let's go back down to 10. Just to show you a function here. Do I still have thread open down here? I'll just do it. Java thread. I'll show you another thread thing. We could tell threads to go to sleep for a period of time. So here, we can tell a thread to sleep for some number of milliseconds. It actually is a class method, so it's owned by the class, so we have to say thread.sleep. But let me show you how this might play out. So I'm going to change this back to 10. But then each time I'm going to say thread.sleep. I'm going to tell it to sleep for 1 second. So 1,000 milliseconds is 1 second. So what that's going to do is in this run method, it's going to print out the name of this thread, then it's going to wait a second, and it's going to increment count, and it's going to spin up. It's going to do that 10 times. So it should take 10 seconds for my thread to finish doing its thing. That should be plenty of time for my prompt to show up somewhere in the middle, assuming their scheduler is doing what I hope it's doing. Oh, this is an opportunity to introduce, have we looked at try catches before? So this guy right here, if we look at the documentation, I go to sleep. You can get really precise. You can do milliseconds and then nanoseconds of scientific-y type stuff. If I go to sleep here, we see that this guy throws an exception. So in modern programming languages, we have something called exception handling, which allows our programs when errors occur to kind of, let's say, either crash or recover gracefully. So this guy is saying, look, something bad can happen. So something called an interrupted exception. So this thread could be externally interrupted while I'm trying to sleep, and there's nothing I can do about that. So the sleep function is saying, look, if that happens, it is on you to handle it. Because if it happens to me, I'm going to throw this exception. Which means that if a function is throwing an exception, it is now our responsibility to deal with it. Now, we have a couple different options here. We can.
You say that they catch the errors. Doesn't necessarily prevent them, but
Yeah, I mean, when an error occurs, because I mean, the thread class is saying, look, when you tell me to sleep, I have no control over what might externally act on me while I'm sleeping for the 1 second you told me to. So if something else, something in the operating system goes and kills your thread for some reason, then it's going to catch that exception here and it's going to say, okay, I'm screaming that something bad happened. You either, well, notice here it says this guy must be caught. So any normal exception gives us the requirement of dealing with that exception. There are things called runtime exceptions that we can choose to ignore. I would say I typically just take the lazy way out and make everything a runtime exception, which basically says Java, behave like old languages and crash like a man or something like that. But in any case, it's asking us to deal with the possibility of, so I'm going to say I want to try to do something. What am I trying to do? I am trying to call this sleep function, which I've been told potentially throws an exception. Specifically, it throws an interrupted exception, which I can put in there. But what I'm really doing here is I'm saying, look, any exception that occurs, because every specialty exception inherits from the top level exception. So think of in the exception world, the top level class called exception is the parent of all exceptions. And its parent at some level will be object. All right. But so the most generic project couldn't be saved. Thank you. The most generic exception is exception, which is a catch-all. Again, this is lazy coding. It's saying, look, if I have an entire function that has 30 different things that throw all sorts of different exceptions, and I don't want to deal with them individually, I can say I'm going to put the entire function inside of a try. And at the very end, I'm going to throw a catch and just say exception, whatever, and then say bad things happened. Something like that. So I might come in here and I might do system.err. So it's an error, println, bad stuff, something like that. So I'm going to try to do this with the expectation that it's probably never going to catch the exception. It's probably going to always work just fine. But since every once in a blue moon, something bad can happen when a thread is sleeping, it requires us to catch that. So I'll try to do the bad stuff and then catch the exception. You don't just have to put the bad stuff in there. You can bring the entire logic of this guy into the try catch. Even though only one of those lines potentially throws an exception, I can just put everything in the try. Just let it do its thing. All right. And as we saw here, Java's happy to scream at you. So it's common, like what I just did. I didn't remember that sleep threw an exception. So I said, okay, I'm going to call the sleep function. I called it. I ran the code. It yelled at me and said, hey, that dude throws an exception. I went and looked at the documentation. I saw that indeed sleep throws an interrupted exception, which tells me I have to deal with it. So I've dealt with it in the most generic way possible. Actually, not in the most generic way possible. The most generic way possible would have been for me to do this. I can say that my run method throws that exception. Now, who called this guy? Well, it got called by start in main. So then main will then, this is me passing the buck to whoever called me. So whoever called this run method, if I say, I'm going to throw any exception that occurs here, that keeps me from having to write this try catch. I'm just saying anything bad that's happening, you're dealing with it. Pass the buck. So in this case, the parent would be the thread class that was started from main, so main would have to deal with it, which actually is as high up as you have to go. So if you have 11 classes down, you've just had inheritance through inheritance through inheritance, and you throw an exception here, you then need to throw it here and throw it here and throw it here and throw it here. You have to keep passing the buck until you finally get up to main, And at that point, it crashes like a normal old school program crashes. All right. I would say this is pretty bad programming. Probably don't make your functions just generically throw anything bad that might happen. But I would call this relatively acceptable. If you have 1,000 lines of code inside of try, and there's maybe 5 or 6 different types of exceptions that could be caught, I can come in here and I can have multiple catches. So what was this? An interrupted exception. So I can do like a system.err.println interrupt exception in here. So it will first catch anything that's an interrupted exception. But if it's an exception other than interrupted, but any other kind of exception, then I have the second catch that's a catch-all. It'll catch the rest of them. You can think of this as kind of like an if and an else if, those kind of things. If you're writing code where these exceptions can occur often, you might want to have as many catches as are needed to deal with each one individually, but unless it's really important code where this is an important thing, I usually just catch the catch-all exception. And instead of saying bad stuff, I might do something like, I think it's e.print stack trace. I think that's what it is. We can quickly find out because E is an exception. So I can click on interrupted exception here, which an interrupted exception is an exception, which is a throwable, which is an object. So I can click on exception. You see all the different subclasses of exception. These are all we have activation exception, bad attribute value, expected exception, yada, yada, yada. All sorts of different kinds of specialty exceptions. But if I go down here, I'm pretty sure there's a print stack trace somewhere. Those are all methods inherited. Print stack trace. I got that from throwable. So here's print stack trace. It actually takes in, it looks like a print stream. So I have to say system.out in there, it looks like. That's where do you want to print the stack trace? I want it to print to the monitor. Let's see if it yells at me about any of this. Nope, it's good. All right, well, so see it running? It's still waiting for my input here. So I can go and type something like LOL and press enter. My program finished because now my scanner read in the thing, but we saw that those other things were happening in the background, even though my code was blocking. I'll just run it one more time so you see it. So my input dot next line from my scanner, this guy right here, that guy's still sitting there waiting for me to enter something, yet I have this thread running in the background doing something. Go ahead.
Do I have to include dot print stack trace? I kind of just left it where it's like.
You don't. I was just showing you something you could do. This is probably a fairly, let's call this a reasonable catch function or catch part of a try catch. I'm teaching you fairly lazy programming here. Good programming, really detailed programming would have a catch for each different kind of exception that could occur. But at the very least, if you do this the first time and you say, look, I'm just going to I have 1,000 lines of code in here. I think that stuff might occur up there. There's probably some stuff up there that might throw an exception. There might not even be, but you could still throw it all in a try catch. But when you have a single catch and say, I want to catch any kind of exception, but then you actually print out what the error was, that will allow you as a programmer, when your program does crash, to see what made it crash. And maybe you go back and add a catch for that specific type of error that you have now found does maybe occur. So it's kind of like my little, I don't know, fire detector, something like that. It'll yell at me and tell me what went wrong. But
Also, that you're going to need to do the try and catch versus it being like an actual error that you have to fix.
well, what the exception is. So if I'm printing out stack trace and it says, oh, file not found error, if I'm doing something with file IO, that will tell me that, okay, I need to make sure I maybe include an if statement somewhere to say, if this file doesn't exist, either create it or don't try to read from it, something like that. So it'll kind of tell you the story, what to do. You have to let it give you the feedback. So this is kind of my lazy way of saying, if there's ever a problem, let me know about it, and I'll decide if it's a common enough issue to update my code to handle it specifically. So I leave a little trap. I would call this good lazy programming that doesn't just get lost in the ether somewhere. If this program is running in production and it does crash, yeah, people might be ticked off or whatever, but at least I'll have some output telling me what went down, and then I can go in and decide if this was a thing or not. All right. So at this point, my thread has actually finished. Remember, my thread only went through 10 times and then it ended. We can see that if I go into my worker bee here, and after this, this guy right here, if I just do like well, I can actually even do it I'll do it after the while loop. It's still blocking in the main program. I'll say this dot name, done. So after it's gone through its while loop 10 times, I'll see that that thread has now ended. The run method is finished, and that thread will then get garbage collected or the equivalent from a CPU scheduler. So I'll run this again. I'm purposely not going to type anything on the keyboard, so it's still waiting for my user input. Every 1 second, my thread is pulsing, pulsing, pulsing. Finally, it's going to say WB1 done. Now my thread has died. I no longer have a thread running in the background, but my blocking code is still waiting for me to enter something. And once I do that, then I get past that blocking line and my program is able to end. Make sense? Now, I can then have multiple threads running in the background. So I'm going to go out to driver here, and I'm going to create a couple more threads. I'll create a WB2 and a WB3. Let's see, WB2 start, WB3 start. All right. Now, each of these guys are going to do their thing, and every 1 second they're going to pulse. We could decide to give them a little randomness. So we can say, give me an amount of time between 500 milliseconds and 2000 milliseconds, something like that. That way they're not on the same, because right now they all wait 1 second. So we should see WB2, WB3. Now I got my variables. So we'll see these 3 different threads, each getting scheduled, each getting their own time. Okay, so we saw that they're not always right in order. They're pretty commonly in order here, but there was something up above where technically it happened one of them missed a 3, 2, 1, 3, 2, 1, 2, 3. Okay. 2, 3, 1. So, well, I don't know. It's possible it didn't. But let's go ahead then and enhance this. Let me just get the program to end. So let's go ahead and add some randomness to our worker bees. So I'm going to import java.util.random. This is the random class. We've worked with that in Java at this point, right? All right, so inside run here, I'll say random r is equal to new random. Now, if I say r.nextInt, it's going to give me a value in the total range of integers. What's the range of integers? Oh, everybody in here should have that number memorized. How big is an integer?
16.
32 bits. What's the range of signed values of 32 bits-ish?
Isn't it like
The power 32.
Huh.
And then power 32.
Close. It'll be, well,
31.
not 10. It'll be 2.
Sorry.
Yeah, 2 to the value of 31 plus or minus that. So roughly negative 2.1 billion to positive 2.1 billion. So if I just say r.nextInt, which is the function in the random class that provides you a random integer across the entire range of integers, it's going to give me some number between negative 2 billion and positive, well, negative 2.1 billion and positive 2.1 billion. Some number between negative 2 to the 31st and positive 2 to the 31st minus 1 is the actual range. Now let's go look at Java random class. And let's see if there's other versions of nextInt. Maybe something that allows me to give it a range so I don't have to manually do it. All right, so so notice here it gives you all the different primitives. I can get the next Boolean, so I'll generate a random true or false, yada, yada, yada. So here's nextInt. Here's a version of nextInt with a bound, since most of the time we're generating integers. Bound says return a pseudo-random uniformly distributed int value between 0, including 0, and the specified value exclusive. All right. So I can say give me a value between 0 and 3,000. And then I could just add, or 0 and 2,000, and then I could just add 500 to it. That'll give me a value between 500 and 2,500. So I'm going to use this version of it. So I'm going to say nextInt 2,000. Call this int delay. So this will give me some number between 0 and 2,000. I want actually a number between 500 and 2,500. So either half a second up to 2.5 seconds. So I will go ahead and I'll say plus 500 here.
Could you explain again why you had 5?
Because if I leave it at 2,000, it's going to give me a value somewhere between 0. So that's 0 delay and 2-second delay. 2,000 milliseconds is 2 seconds. I actually want my shortest delay to be a half a second, which is 500 milliseconds, and my longest delay to be 2,500. So I had to generate me a random number between 0 and 2,000, and then I just added a 500 to it. So now it'll be 500 to 2,500. So instead of telling it to sleep for 1 second, now I'll tell it to sleep for my delay. And hopefully we get a decent rotation of numbers that they're far enough apart in this range that we'll feel the thread sleeping for different amounts of time behind the scenes. So we'll go ahead and run this. All right. So WB1 just finished. WB3 just finished. The WB2 must have had the longest delay. Oh. Yeah, each one is their own instance. So we have, in this particular case, there's actually 4 threads. We have the main thread, the one that automatically starts when we just create our program, that runs inside of a thread. And then we are artificially creating 3 additional threads. We're calling them worker bees. So we have WB1, WB2, WB3. Each of those guys, let me just get that program to end. Each of those guys has their own version of the run method, which will have their own different delay. And then they're sleeping a different amount of time. The one thing that's a little bit weird here is when you call thread.sleep like we're doing here, sleep in this case is what's called a static method. It's owned by the class itself, not instances of the class. So that's why we're not saying this dot sleep. We're saying thread dot sleep. And we're relying on the thread class to schedule for, the thread class to figure out which thread called this. Because each one's going to get its own sleep amount of time. So there's some more magic happening behind the scenes for us. Now, I'll go ahead and just so we kind of know, I'll say system.out.println. And we'll say this dot name. We'll concatenate onto that. And we'll say sleeping for, and we'll add to that delay milliseconds. Put an extra little space here. So now each of those threads will report to us how long they will be sleeping right at the beginning. This is not inside the loop. So before the loop, we generate what's the delay going to be for this particular thread. Then we're going to say, hey, my name is WB2 and I'm going to sleep for 1000 milliseconds. And then we get into our counter. So WB1, WB2, WB3 will each get their own count variable that will count from 0 to 10. And they will do their own while loop. They'll announce their own name. They'll sleep for, in this case, a more random amount of time rather than just 1 second each. And we should get some interesting behaviors. All right, so we saw a couple different numbers there for how long they're sleeping. This guy's about a second, 2.3 seconds, 1.7 seconds. All right. Now, something else we can do if we want to really push this. Oh, it's waiting for me to enter something. So are we convinced that these things are running in the background now? All right, so I can take my scanner out. All right, so I'll go ahead and dump the scanner here. Well, that way I don't, in order to stop the program, I don't have to type something in. And then what we're going to do here, just to get this going, I'm gonna say an int num threads is equal to, let's create 10 threads. And I'm going to say actually, I don't even need num threads here. For int I is equal to 0, I is less than 10, I plus plus. And what we're going to do here is we're going to create 10 threads and tell each of those threads to start. And then I'm going to ask you some questions about this. So we're going to say new worker bee WB concatenated with I dot start. So let me go ahead and run this here real quick. I was testing you. Nobody caught that I purposely left the semicolon off there. Typo. It's on you.
My bad.
Apology not accepted. All right, so we got 10 different worker bees going here. Notice here at the beginning, they all had their different different sleep timers. They're all kicking. Okay, so one of them just finished, yada yada yada. So they're still running. So we got 10 different guys running in the background here. Now, I did all that with just that line, those lines of code right here. Tell me what's happening here and what my limitations are. What do I no longer have access to here? So what can you, somebody help me explain this code? What's happening here?
For about 10 times.
Okay, I'm doing something 10 times. Okay.
10 objects.
Okay. So this guy right here, that is how we create an instance of an object, right? But we usually have something before the new keyword. What do we usually put before the new keyword when we create instances of objects? Equal to what?
Like worker bee and the name we have.
A variable name,
Yeah.
right? We typically would say something like worker bee, WB, whatever, is equal to a new worker bee, WB, whatever. We usually say that. But why does this work? WB here holds a value. That's what variables do, right? Variables are built as empty containers that are capable of holding a value. Now, we typically will fill a variable with that value all on the same line. But when do we use variables? Under what circumstances do we use a variable? Yeah, well, or when we want to use it again, we need access to it after this line of code, right? So variables are not requirements. We don't have to use a variable in every situation where we could use a variable. We might want something to just happen, and we're never going to go back to it again. So I don't need a variable to get to that place in memory. And in this case, maybe we would, depending on the problem we're solving. So I'm not saying never put worker bees into a variable, but I am saying only use variables if it's necessary. So in this case, what's happening in here is this guy is boiling down to a pointer which points to a place in memory where this worker bee actually is. Then I'm telling that guy to call his start function. This is the same thing as me right here saying WB dot start. And it's not even a trick. At runtime, variables will resolve to their value. The value of WB here is whatever was generated by that code right there. So WB during runtime will boil down to, some memory address that is where that actual thing lives. And I'll tell that actual thing to call his start function. All right. So in this particular case, I have a for loop that's going to do something 10 times. What am I going to do 10 times? I'm going to generate an instance of worker bee. I'm not going to store it anywhere because I've decided I don't need to access it again. It's just going to go off and do his own asynchronous thing. And I'm going to then tell that guy to start. Because if I don't tell him to start on that line, and I come down to this line and say, oh, I want him to start now. Then I'm going to need a variable to start him. Make sense? Now I could use a single variable. I can have a single worker bee WB and then go through and keep overwriting that variable with new values and then say WB.start or whatever, but that's not required. So I can change this to 100 worker bees and tell those guys to get kicking. At some point, we're going to get, Java will yell at, oh, it just did. We tried to create too many worker bees. Java, but the default Java virtual machine has a limit to the number of threads we can request by default. we can give it command line arguments to say, to make that limit higher. Let me have more threads. So it looks like maybe I kind of saw a 74 there. So maybe we have 75. I see 75. I don't know what the biggest value is, but some 76. Oh, you saw 77? So let's just say it looks like something in the ballpark of 80 threads was our max. All right. Questions, comments, concerns, bribes. One thing, and I will confirm this through an announcement or something. On Thursday, I think we're going to have class on Zoom only. I have a guy coming to my house to fix something, and I don't have to babysit him, but I don't want to leave him there with my wife alone. So I'll confirm that though. But plan on Zoom unless you hear otherwise, but I will tell you either way.
The final.
Oh, the final, and I'll talk about next class. I'm going to put the exam up Monday morning. You just need to submit it by 11:59 p.m. on Friday night next week. You figure out when you have the chunk of time to do the exam. I'll tell you more about what's on the exam next class. Somebody tried to remind me at the beginning so I don't go off of my thing and not share the screen again and crap like that. All right, I'll see everybody on Thursday. Well, how is a tower guard helmet different? Okay.